a white colored ash is formed. That white colored ash is magnesium oxide. White colored ash. That white colored ash is magnesium oxide. 2 Mg means 2 magnesium atom. O2. O2 is 2 oxygen atom. Then in the product side 2 MgO. Number of magnesium atom is 2. And Fe2O3s. That means ferric oxide in solid state. SO2G. That means sulfur dioxide in, yes, very good, gaseous phase using photochemical decomposition of silver halide. Photography using photochemical decomposition of silver halide. We know that silver halide, silver chloride or bromide. Good evening, my dear students. Our first chapter in chemistry is chemical reaction and equations. Chemical reactions and equations. These are some examples of chemical changes: roasting of iron, cooking food, germination of seed, ripening of fruits. We know that what are chemical changes and what are physical changes. Chemical change is a permanent change. Chemical change is a permanent change and physical change is a temporary change. These are chemical changes. Roasting of iron, it's a permanent change. Iron change to rust, it's a permanent change. And a new molecule is formed. During chemical changes, a new molecule is formed. This type of reaction is called chemical. This type of changes are called chemical changes and the reaction is called chemical reaction. Chemical changes are permanent changes and physical changes are temporary changes. Okay, a chemical reaction occurs when a chemical change takes place. A chemical reaction occurs when a chemical change takes place. Let's do some experiment. Take a piece of neat and clean magnesium ribbon and burn it. Then collect the ash in a watch glass. What do you observe? A white colored ash is formed. That white colored ash is magnesium oxide. White colored ash. That white colored ash is magnesium oxide. The magnesium ribbon reacts with the oxygen in the air to form magnesium oxide. Magnesium oxide is the white colored ash. Burning of magnesium ribbon in air. Burning of magnesium ribbon in air to form magnesium oxide. So magnesium changed to magnesium oxide. Magnesium oxide is a new substance. A new product will formed. That means this reaction is a chemical reaction. Here a chemical change is occur. Burning of magnesium ribbon. It's a chemical change. So the reaction is a chemical reaction. Magnesium react with oxygen or magnesium react in the presence of air to form magnesium oxide. Let's do another experiment. Take equal amount of potassium iodide. Potassium iodide and lead nitrate. Equal amount of potassium iodide and lead nitrate in a beaker or test tube. Then add potassium iodide to lead nitrate solution. Add potassium iodide to lead nitrate solution. What do you observe? A yellow colored precipitate is formed. When we added potassium iodide to lead nitrate solution, a yellow colored precipitate will formed. A yellow colored precipitate. That means a new product is formed. Here a new product is formed. So this reaction also a chemical reaction. Potassium iodide react with the lead nitrate solution. Potassium iodide react with the lead nitrate solution. A yellow precipitate is formed. A yellow precipitate is formed. That yellow precipitate is a new product. So the reaction is a chemical reaction. Potassium iodide react with the lead nitrate. Yellow precipitate is lead iodide. Okay. Our first experiment is burning of magnesium ribbon. A white tinted ash is formed. That white tinted ash is magnesium oxide. Magnesium react with the oxygen to form magnesium oxide. Next next experiment is reaction of potassium iodide and lead nitrate. Lead nitrate solution is added to, or potassium iodide solution is added to lead nitrate solution. A yellow precipitate is formed. Then do another experiment. Take a few zinc granules in a conical flask. This is the conical flask. Take a few zinc granules, zinc metal, in a conical flask or test tube, and then added dilute sulfuric acid or dilute HCl. Dilute sulfuric acid or dilute HCl. എന്തൊക്കെയാണ്? Take a few zinc granules in a conical flask and add dilute sulfuric acid or dilute HCl solution. Then what do you observe? A small bubbles coming out. These bubbles indicate the presence of gas. The gas is hydrogen gas. Gas is hydrogen gas. Hydrogen gas is formed and evolved. Zinc react with the dilute acid, dilute sulfuric acid or dilute HCl. It liberate hydrogen gas. It liberate hydrogen gas. Then touch the conical flask. Touch the bottom portion of the conical flask or test tube. Then what do you feel? It's very hot. Why? Because zinc react with the sulfuric acid or dilute HCl. It liberate heat energy. It liberate heat energy. That's why the conical flask become hot. In this reaction, zinc react with the sulfuric acid. It liberate hydrogen gas and heat. Okay. In this reaction, also hydrogen gas is also formed and heat energy is also liberated. Zinc is a metal. We know that metal react with any acid. It liberates hydrogen gas. From the above three activities, we can say that any of the following observations help us to determine whether a chemical reaction has taken place. Change in state. The change in state, that is solid, liquid or gas. Change in color. In potassium iodide solution, a yellow colored precipitate is formed. And evolution of gas. In this experiment, hydrogen gas is evolved. Evolution of gas and change in temperature. Here also temperature is evolved. It's an exothermic reaction and hydrogen gas is also formed. Okay. Then our first experiment is burning of magnesium ribbon. Magnesium ribbon burned to form a white tinted ash. The white tinted ash is magnesium oxide. It's a white colored ash. It's magnesium oxide. Magnesium ribbon changed to magnesium oxide because magnesium react with the oxygen in the air to form magnesium oxide. Magnesium oxide is the product. A new product will formed. So the reaction is a chemical reaction. Here equal amount of potassium iodide and lead nitrate are taken and then slowly added. Potassium iodide is slowly added to lead nitrate solution. A yellow colored precipitate is formed. Yellow colored precipitate is formed. That yellow colored precipitate is lead iodide. Yellow colored precipitate is lead iodide. Then last experiment is zinc granules react with the dilute acid, dilute sulfuric acid or dilute HCl. Zinc is a metal. Metal react with the dilute acid. Hydrogen gas evolved. This reaction is exothermic because the bottom portion of the conical flask is very hot. That means in this reaction, the heat energy evolved. Heat energy evolved and hydrogen gas is also formed. Dilute sulfuric acid react with the zinc granules to form hydrogen gas. These are the conditions. And next topic is chemical equation. Our first experiment is burning of magnesium ribbon. Magnesium burn in the presence of air. That means magnesium react with the oxygen. Magnesium react with oxygen to form magnesium oxide. Magnesium oxide, that is a white tinted ash. It's magnesium oxide. Magnesium react with the oxygen to form magnesium oxide. Our word equation is magnesium plus oxygen gives magnesium oxide. Magnesium and oxygen are reactant. Magnesium and oxygen are reactants. They react to form a product. This one is the product. Product is magnesium oxide. So magnesium and oxygen are reactants and magnesium oxide is the product. Okay. Is it clear? Magnesium and oxygen are reactant and magnesium oxide is the product. The new substance, when a chemical reaction takes place, a new substance is formed. The new substance is the product. And the reactant molecules are reactants. Here magnesium and oxygen are the reactant. The reactants are written on the left hand side. The reactants are written on the left hand side, LHS side. Reactants are written on the LHS, left hand side, and product. Product evidiyana. Similarly, products are written on the right hand side. Products are written on the right hand side. Reactants are written on the left hand side and products are written on the right hand side. And a plus sign is separated between them. Magnesium plus oxygen. That means magnesium and oxygen are reactants. Magnesium and oxygen are reactants and written on the left hand side of the equation. Then right hand side, product. Then the arrow mark. The arrow mark pointed towards the product side. Arrow mark pointed towards the arrow of the arrow mark pointed towards the product side. Okay, is it clear? Reactant written on the LHS side and product on the RHS side. The arrow is projected on the product side. This is the word equation. Then magnesium. We know that magnesium, the symbol of magnesium is Mg. Symbol of magnesium is Mg. It reacts with the oxygen. It reacts with the oxygen. Oxygen is O2. Mg plus O2 gives MgO. MgO is magnesium oxide. This is the chemical equation. Magnesium react with oxygen to form magnesium oxide. Magnesium and oxygen are reactant. And MgO is the product. MgO is the product. Mg and O2 is the reactant and MgO is the product. Okay. Next one, balanced chemical equation. This equation is balanced or not? Balanced or unbalanced equation? Balanced or unbalanced? Balanced equation means the total number of atoms in the reactant side is equal to total number of each atoms in the product side. Total number of each atom in the reactant side is equal to total number of each atom in the product side. If the number is not equal, that equation is not balanced. We will check. Here in the reactant side, this is the reactant and MgO is the product. In reactant side, how many magnesium atom? In reactant side, only one. Mg, only one magnesium atom. And another reactant is oxygen. How many oxygen atom? Oxygen atom is O. How many oxygen atom? It's O2. That means 2 oxygen atom. 2 oxygen atom. Then in the product side, MgO is the product. How many magnesium atom? MgO. one magnesium and one oxygen. Number of magnesium atom is only 1 and number of oxygen atom. Here formula of magnesium oxide is MgO. Here number of oxygen atom is only 1. Is this equation is balanced or unbalanced? This equation is unbalanced because in the reactant side number of oxygen is 2 and in the product side number of oxygen is only 1. Then balance this equation. How can we balance this equation? We know that 1 into 2 is equal to 2. 1 into 2 is equal to 2. Put 2 in front of magnesium oxide. Here. Put 2 in front of magnesium oxide. Then count the oxygen atom in the product side. 2 MgO. That means 2 molecule of magnesium oxide. MgO plus MgO. 2 molecule of magnesium oxide. 2 MgO means 2 molecule of magnesium oxide. That means 2 magnesium atom and 2 oxygen atom. The number of 2 MgO, number of magnesium atom is, now the number of magnesium atom is not 1, it's 2. And number of oxygen atom, 2 MgO, 2 into 1, 2. Number of oxygen atom is 2. Now, number of oxygen atom on reactant side and the product side become equal. But the number of magnesium atom in the reactant side is only 1, but the product side is 2. So, I will put 2 in magnesium side, 2 Mg. Then check, 2 Mg plus O2 gives 2 MgO. Then recheck the equation. Number of magnesium atom, 2 Mg. 2 Mg means 2 magnesium atom. O2. O2 is 2 oxygen atom. Then in the product side 2 MgO. Number of magnesium atom is 2. This 2 is common for magnesium and oxygen. Number of magnesium atom is 2 and number of oxygen atom is 2. So the number of reactant, number of atoms, number of each atoms in the reactant side become equal to product side. So this equation is balanced. 2 Mg plus O2 gives 2 MgO. 2 Mg plus O2 gives 2 MgO. Do not write anything here or here. Do not write any number here or here. Write the number in this portion only. Okay, 2 Mg plus O2 gives 2 MgO. Is it clear? First count the atom, then add appropriate numbers or coefficient to the left side of the compound or element. Another equation, zinc react with the sulfuric acid. Zinc granule is react with the dilute sulfuric acid or dilute HCl to liberate hydrogen gas. Our third experiment, zinc react with the sulfuric acid gives zinc sulfate and hydrogen. This one is the word equation and write the chemical equation. Zn plus H2SO4 gives ZnSO4 plus H2. Zn plus H2SO4 gives ZnSO4 plus H2. Zn zinc, H2SO4 sulfuric acid, ZnSO4 is zinc sulfate, H2 is the hydrogen gas. Then zinc and sulfuric acid are reactant. Okay, zinc and sulfuric acid are reactant. Zinc sulfate and hydrogen are products. Zinc sulfate and hydrogen are products. Okay. Easy ആക്കാൻ വേണ്ടി നമുക്ക് വേണമെങ്കിൽ ഇങ്ങനെ ചെയ്യാം. To balance a chemical equation, first draw boxes around each formula. Zinc, sulfuric acid, zinc sulfate, H2. Okay. And do not change anything inside the box while balancing the equation. Do not write anything inside the box. Okay. Do not write anything inside the box. Then count the number of atoms. Zinc atom. Zinc atom in the reactant side. Only one. One zinc atom. Number of zinc atom in the reactant side is 1. Then zinc, then H2SO4. H2SO4, first atom is hydrogen. Number of hydrogen atom in the reactant side. H2SO4. Number of hydrogen atom is 2. Then number of next element is sulfur. Number of sulfur atoms in the reactant side. Total number of sulfur atoms in the reactant side. It's only 1. H2SO4, only 1 sulfur atom. Then count the oxygen atom in the reactant side. Oxygen, it's 4. Zinc atom 1, hydrogen 2, sulfur 1, oxygen 4. Then next part, product side. In product side, number of zinc atom. ZnSO4, ZnSO4, that means only 1 zinc atom. Then sulfur atom, number of sulfur atom, ZnSO4 plus H2, total number of sulfur atom in the product side. It's only 1. And total number of oxygen atom in the product side, oxygen, it's 4. Then total number of hydrogen atom in the product side, hydrogen 2. Then check the values, reactant and product. Zinc 1, hydrogen 2, sulfur 1, oxygen 4. That means this equation is already balanced. This equation is already balanced. Okay. Number of each atom on the reactant side is equal to number of each atom on the product side. So this equation is balanced. This is a balanced chemical equation. But Mg plus O2 gives MgO. That equation is not balanced. That is unbalanced equation. Then we will balance and we will get this form. 2Mg plus O2 gives 2MgO. This one is balanced. Okay. Then do another example. Fe, iron, plus H2O. H2O is water. To form Fe3O4 plus H2. Fe plus H2O gives Fe3O4 plus H2. Balance this equation. Count the atoms. In the product side and the reactant side. Fe and H2O are reactants and Fe3O4 and H2O are products. Then count the atoms. Number of iron atom in the reactant side. Number of iron atom. Yes, number of iron atom in the reactant side is only 1. Number of hydrogen atom. H, not hydrogen molecule, hydrogen atom. Number of hydrogen atom in the reactant side. It's H2O, H2. Number of hydrogen atom is 2. Then number of oxygen atom. Number of oxygen atom in the reactant side is 1, H2O. Only 1 oxygen atom. Then in the product side, number of Fe3O4, number of ion. Fe3, 3. And number of oxygen, O4. So number of oxygen atom is 4. And number of hydrogen atom, H2. Is this equation is balanced or unbalanced? Is this equation is balanced? Yes, it's unbalanced equation. So balance this equation. How to balance this equation? Add appropriate number. I am going to balance iron first. Here only 1 iron atom, but here number of iron atoms are 3. I am going to balance iron. I will put 3 in front of iron. I will put 3 in front of iron. So 3Fe. 3Fe means number of iron atoms. Number of iron atom 1 into 3. Total number of iron atom in 3Fe. That is 3. Number of iron atom is 3. Number of iron atom in reactant side is 3 and number of iron atom in product side is also 3. Then hydrogen is already balanced and then balance oxygen atom. In product side, 4 oxygen atoms are present, but in the reactant side only 1 oxygen atom is present. Then how to balance oxygen atom? Yes, correct. I will put 4 here. 4H2O. 4H2O. Number of oxygen atom is 4. 1 into 4, that is equal to 4. Number of oxygen atom is 4. But in 4H2O, number of hydrogen atom. How many hydrogen atom present in 4H2O? 4H2O means 4 H2O molecules. H2O, 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 H2O. Total number of hydrogen atom. Total number of hydrogen atom is 2 into 4. 2 into 4, 8. 2 into 4, 8. So, in 4H2O, the number of hydrogen atom will change. The number of hydrogen atom, total number of hydrogen atom in 4 molecule of H2O is 8. Here in the product side, here only 2 hydrogen atoms. How to balance? Yes, correct. Put 4 in hydrogen side. 2 into 4, that is equal to 8. 2 into 4 is equal to 8. Now the equation is balanced. Then recheck. 3Fe plus 4H2O gives Fe3O4 plus 4H2. Count the number of atoms. In reactant side, number of iron atom 3. Product side, number of iron atom 3. In reactant side, number of hydrogen atoms 4H2. 4 into 2, 8. And product side, number of hydrogen atom 4H2. 4 into 2, 8. And in the reactant side, number of oxygen atom 4O. 4 into 1, 4. And in the product side, number of oxygen atom Fe3O4, O4. So the equation is balanced. Iron atom 3, hydrogen atom 8, oxygen atom 4 on both reactant and product side. So the equation is balanced. 3Fe plus 4H2O gives Fe3O4 plus 4H2. Okay, is it clear? This equation is balanced equation. Okay, is it clear? Then writing the symbol of physical state. If the substance is solid, we can write this. Solid. Yes. If the substance is liquid, we can write like this. L. L in bracket. If the substance is gas, we can write like this. And if the substance is dissolved in water, that solution is aqueous solution. Any substance, any solid substance or any substance dissolved in water, that solution is known as aqueous solution. And we will write like this, AQ in bracket. Okay, this for solids, this for liquid, this for gas, and this for aqueous. Okay, in this equation 3Fe is, that means iron. We know that iron in solid state, and 4H2OG, 4H2OG, that means water in gaseous state, water vapors or steam. H2O, H2OS, this indicates water in the solid state, that means ice. H2OL, this indicates water in liquid state, normal water. And H2O gas, this indicates water is in the gaseous state, or gaseous state, that is water vapor or steam. Here, iron in the solid state and water in the gaseous state, that is steam. Iron react with the steam. Iron react with the steam to form Fe3O4, iron oxide. Fe3O4 in solid state and to form and also form hydrogen gas. Hydrogen is a gas, G. Okay. The physical state of iron is solid. In this equation, physical state of iron is solid. Physical state of water is gas. Physical state of Fe3O4 is solid. And physical state of hydrogen is gas. Okay. Is it clear? Solid is used for water H2S, H2OS. Is indicate it's ice. This one is liquid. This one is water vapor or steam. Then next reaction, CO plus 2H2O gives CH3OH. Here mention the reaction condition. Reaction condition mentioned above or below the arrow mark. This is the reaction condition. CO, carbon monoxide, react with the hydrogen at 340 atmospheric pressure. 340 atmospheric pressure is the reaction condition. It will write on top or bottom of the arrow mark to form CH3OH. Here carbon monoxide in gaseous state, hydrogen in gaseous state, CH3OH in liquid state. Is this equation is balanced? Check. Number of carbon atom in the reactant side. Carbon only 1 and oxygen only 1. Hydrogen 2H2. Hydrogen 1 H2 molecule have 2 hydrogen atom. 2 H2 have 2 into 2, 4 hydrogen atoms. In the product side, number of carbon atom CH3OH, number of carbon atom is only 1 and number of hydrogen atom is CH3OH. CH3, 3 hydrogen plus OH, 1 hydrogen, 3 plus 1, 4. Total number of hydrogen atom on the product side is 4. And oxygen atom, oxygen, CH3OH, oxygen 1. Carbon 1, oxygen 1, hydrogen 4. So the equation is balanced. Number of each atom on the reactant side is equal to number of each atom on the product side. So the equation is balanced. Then another equation, 6CO2 plus 12H2O gives C6H12O6 plus 6O2 plus 6H2O in the presence of sunlight and chlorophyll. This is photosynthesis process. Chemical equation of photosynthesis. Carbon dioxide react with water in the presence of sunlight and chlorophyll. The reaction condition is sunlight and chlorophyll. Carbon dioxide react with water in the presence of sunlight and chlorophyll to form C6H12O6. C6H12O6 is glucose. Glucose, oxygen and water. Carbon dioxide in aqueous form. Carbon dioxide in aqueous form. Aqueous, that means carbon dioxide dissolved in water. Then water in liquid form, glucose in aqueous form, oxygen in aqueous form, water in liquid form. Okay, this is the reaction condition. In photosynthesis, the reaction takes place in the presence of sunlight and chlorophyll. Sunlight and chlorophyll. In the above equation, the reaction takes place at 340 atmospheric pressure. The pressure of the reaction condition, that particular reaction is 340 atmospheric pressure. Okay, is it clear? Then write the balanced equation for the following chemical reactions. First question, hydrogen plus chlorine gives hydrogen chloride. Hydrogen plus chlorine gives hydrogen chloride. Hydrogen is H2. Hydrogen plus chlorine. Chlorine is Yes, correct. Cl2 to form hydrogen chloride, HCl. Hydrogen plus chlorine gives hydrogen chloride. Hydrogen is H2, chlorine is Cl2, and hydrogen chloride is HCl. Is this equation is balanced or not? Check it. Here, hydrogen and chlorine are reactants and HCl is the product. These are the reactants and HCl is the product. Then count the number of atoms. Count the number of each atom. Number of hydrogen atoms. Number of hydrogen atoms. Number of hydrogen atom is 2. And number of chlorine atom. Number of chlorine atom is 2. Number of hydrogen atom on reactant side is 2. And number of chlorine atom on reactant side is also 2. And then move to the product side. Product is HCl. Number of hydrogen atom in the product side. HCl. How many hydrogen atom? Only one hydrogen atom. Only one hydrogen. And how many chlorine atom? Only one chlorine. HCl. Number of chlorine atom present in the product side is only 1. Is this balanced? No. This equation is unbalanced. Then balance the equation. In the reactant side, the number of hydrogen atom is 2. But in the product side, the number of hydrogen atom is only 1. How to balance? I will put 2 here. 2 HCl. Then count the number of hydrogen atom in the product side. 2 HCl. 2 HCl means 2 molecule of HCl. 2 HCl molecule. HCl, HCl. 2 HCl molecule. 2 into 1 HCl containing only 1 hydrogen atom. 2 into 1, 2. Here number of hydrogen atom 2. In 2 HCl, number of chlorine atom. Number of chlorine atom is not 1, it's 2. 1 HCl containing only 1 chlorine atom. 2 HCl, 2 molecule of HCl containing 2 chlorine atom. 1 into 2, 2. Okay, then check is this equation is balanced or not. H2 plus Cl2 gives 2 HCl. H2. 2 hydrogen atom in the reactant side. In the product side, it's also 2 hydrogen atom. In the reactant side, number of chlorine atom is 2 and the product side number of chlorine atom is also 2. So, the equation is balanced. The balanced equation of balanced equation is hydrogen plus H2 plus Cl2 gives 2 HCl. Then, next question. Barium chloride react with the aluminium sulfate. Barium chloride, the chemical formula of barium chloride. Chemical formula of barium chloride is BaCl2. Chemical formula of barium chloride is BaCl2. Barium chloride react with the aluminium sulfate. The chemical formula of aluminium sulfate is Al2SO4 thrice. Aluminium sulfate is Al2SO4 thrice. Barium chloride react with the aluminium sulfate. Barium chloride plus aluminium sulfate to give barium sulfate and aluminium chloride. Barium sulfate and aluminium chloride. The chemical formula of barium sulfate. Chemical formula of barium sulfate is BaSO4. BaSO4, it's barium sulfate. And aluminium chloride. Aluminium chloride. Aluminium chloride is AlCl3. AlCl3. Chemical equation is BaCl2 plus Al2SO4 thrice gives BaSO4 plus AlCl3. Here, barium chloride and aluminium sulfates are reactants. And barium sulfate and aluminium chloride are products. Okay. Then check this equation is balanced or not. Count the number of atoms, count the number of each atom on both sides. Number of barium atom. BaCl2, only one barium atom. And number of chlorine atom, BaCl2. Number of chlorine atom is 2. Then next element is aluminium. Aluminium. Number of aluminium atom. Al2SO4 thrice. Number of aluminium atom is 2. Number of aluminium atom is 2. Then count number of another atoms. And next atom is sulfur. SO4 thrice. SO4 thrice. This 3 is common for sulfur and oxygen. So number of sulfur atom is SO4 thrice. That means 3 SO4 groups. 3 SO4. So the total number of sulfur in SO4 thrice group is 3. 3 SO4 groups. SO4 thrice means 3 SO4 group. And number of oxygen atom. 3 SO4 groups. That is SO4, SO4, SO4. Number of oxygen atom in 3 SO4 groups. 3 into 4. 3 into 4, that is equal to 12 oxygen atom. Total 12 oxygen atom present in 3 SO4 groups. Okay. Then count number of atoms on product side. Barium. Barium, only 1. Then next one sulfur. Sulfur, only 1. Next one oxygen, SO4. Oxygen is 4. Then aluminium. Aluminium is AlCl3. Here aluminium is only 1. Then chlorine, Cl. Cl is 3. Is this equation is balanced or not? This equation is not balanced. This is unbalanced equation because number of chlorine in reactant side is 2 and the product side is 3. It's not equal. And the number of aluminium on product reactant side is 2 and the product side is only 1. It's not equal. Number of sulfur atom and number of oxygen atom, that are not equal. So this equation is unbalanced equation. So balance this equation. Then how to balance? I am going to balance aluminium first. Al2SO4. Al2SO4. Number of aluminium atoms in the reactant side is 2. And the number of aluminium atom in the product side, in that side only 1 aluminium atom. Then I will put 2 in front of aluminium. Aluminium chloride, 2. Now number of aluminium, 2AlCl3. 1 into 2 is equal to 2. Number of aluminium atom is 2. And number of aluminium atom in the reactant side, that is also 2. Now aluminium is balanced. 2AlCl3. So the number of chlorine will change. The 2AlCl3. Number of chlorine atoms in the 2 molecule of AlCl3. 2 into 3. 2 into 3. 2 into 3 is 6. 6 chlorine atom. 2 molecule of AlCl3 containing total 6 chlorine atoms. But in the reactant side, BaCl2, only 2 chlorine atom is present. So 2 change to 6. How to change? 2 into 3 is equal to 6. So I will put 3 here. 3 BaCl2. In 3 BaCl2, number of chlorine atom is 3 into 2, 6 chlorine atom. In the reactant side, 6 chlorine atom, and in the product side also number of chlorine atom is 6. So the chlorine is balanced. But here I will put 3 in front of barium chloride, 3 BaCl2. So the number of barium atom, check the number of barium atom. 1 BaCl2 containing 1 barium atom. I will put 3. So, number of barium atom in 3 BaCl2. 1 into 3, 3 barium atom. 3 molecule of barium chloride containing 3 barium atoms. So, balance the barium atom. In the product side, here also 1 barium atom. So, I will put 3 here. 3 barium, 1 into 3, 3. 3 molecules barium sulfate. Okay. 3 molecule barium sulfate. 1 molecule of barium sulfate containing only 1 sulfur atom. Here 3 molecule of barium sulfate, 3 BaSO4. So the number of sulfur atom in 3 molecule of barium sulfate, 1 into 3, 3. Number of sulfur atom is 3. And number of oxygen atom in 3 molecule of barium sulfate, BaSO4. BaSO4, 1 molecule of BaSO4 containing 4 oxygen atom. 3 molecule of BaSO4, 3 barium sulfate molecule containing 3 into 4, total 12 oxygen atom. Okay, in the product side, number of sulfur is 3. And in the reactant side, now reactant side number of sulfur atom is also 3. And in the product side, number of oxygen atom is 12. Now the product side number of oxygen atom in the reactant side is also 12. Now this equation is balanced. 3 BaCl2 plus Al2SO4 gives 3 BaSO4 plus 2 AlCl3. Then recheck the number of atoms. Barium 3 in the reactant side, 3 barium on the product side. Chlorine, number of reactant molecule, 6 chlorine atoms. In the product side also 6 chlorine atoms. Aluminium in the reactant side 2 and in the product side also 2. And sulfur in the reactant side 3, in the product side 3. Oxygen is 12, in the product side also 12. So this equation is balanced. Okay, is it clear? The balanced equation is 3 BaCl2 plus Al2SO4 thrice gives 3 BaSO4 plus 2 AlCl3. Is this clear? Then do the next one. Next one is sodium plus water. Sodium plus water gives sodium hydroxide plus hydrogen. Sodium is, yes, Na plus water. Water is H2O. Gives sodium hydroxide. Sodium hydroxide is NaOH. And hydrogen gas. And hydrogen is H2. Then check this equation is balanced or not. Here sodium and water are the reactants, NaOH, sodium hydroxide and hydrogen are the products. Then count the atoms. In the reactant side, number of sodium atom 1, number of hydrogen atom 2, number of oxygen atom 1. Okay. In the product side, number of sodium atom 1, number of oxygen atom 1, number of hydrogen atom, is it only 1? No, number of hydrogen atom in NaOH, 1 hydrogen atom is present and NaOH and hydrogen H2 are 2 products. In hydrogen molecules, the number of hydrogen atom is 2. So, total hydrogen atom in the product side 1 plus 2 that is equal to 1 plus 2 that is equal to 3. Total number of hydrogen atom in the product side is 3. Is this equation is balanced? This is unbalanced equation. Na plus H2O gives NaOH plus H2. How to balance? Na 1 1, oxygen 1 1, hydrogen 2 1. How to balance? I will put 2 here, 2 molecule of water. Then number of hydrogen atom 2 into 2 is equal to 4. 4 molecule of water. And now the number of oxygen atom is also changed. 2 molecule H2O. 1 molecule of H2O containing only 1 oxygen atom. 2 molecule of H2O. 2 into 1 or 1 into 2, that is equal to 2. Oxygen atom is equal to 2. Then in the product side, number of oxygen atom is only 1. So I will write 2 here. 2 NaOH, 2 NaOH. So the number of oxygen atom, now the number of oxygen atom is 1 into 2 is equal to 2. But the number of oxygen and number of hydrogen is also changed. Number of sodium and number of hydrogen is also changed. In 2 NaOH, number of sodium atom, 2 NaOH, 1 into 2, that is equal to 2. In 1 molecule of sodium hydroxide, number of sodium atom is 1. We will write 2 here. So 2 moles of NaOH, 2 into Na, 1 into 2 or 2 into 1, that is equal to 2. Number of hydrogen atom, 2 molecule of NaOH contains 2 hydrogen atom. 2 hydrogen atom. 2 hydrogen atom, and here also 2 hydrogen atom is present. So 2 plus 2, 4. Then in the reactant side only 1 sodium is present. Nitrogen alla sodium, 1 sodium is present. So I will write 2 here, 2 Na. 2 Na plus 2 H2O gives 2 NaOH plus H2O. Now the equation is balanced. Number of sodium atom in reactant side 2 and the product side is also 2. Number of hydrogen on the reactant side is 4 and the total number of hydrogen on the product side is also 4. And number of oxygen in the reactant side is 2 and the product side is also 2. So the equation is balanced. Okay, is it clear? Do one more. Write a balanced chemical equation with state symbol for the following reactions. Solution of barium chloride and sodium sulfate in water react to give insoluble barium sulfate and solution of sodium chloride. Solution of barium chloride. Barium chloride. The formula of barium chloride is BaCl2 plus sodium sulfate. Sodium sulfate. The formula of sodium sulfate is Na2SO4. Sodium sulfate in water. That means it dissolved in water. Dissolved in water. Aqueous solution. Aqueous solution. React to give insoluble barium sulfate. React to give insoluble barium sulfate and the solution of sodium chloride and the solution of sodium chloride NaCl. Okay. BaCl2 plus Na2SO4 gives BaSO4 plus NaCl. Then check is this equation is balanced or not. Barium chloride and sodium sulfates are reactants and barium sulfate and sodium chloride are products. Barium, number of barium atoms in the reactant side, only 1. Number of chlorine atom is 2. BaCl2, number of chlorine atom 2. And number of sodium atoms Na2SO4, number of sodium atom 2, Na2. And number of sulfur 1. Number of oxygen SO4, number of oxygen atom is 4. And in the product side, barium, number of barium atom BaSO4, Ba1. SO4, number of sulfur, only 1. Oxygen SO4, oxygen atom is 4. And sodium NaCl, only 1. Chlorine Only one. Barium is balanced, sulfur is balanced, oxygen is balanced. But number of sodium and chlorine is not balanced. Here in the reactant side, number of sodium atom is 2 and the product side number of sodium atom is only 1. I will put 2 here, 2 NaCl. Now the number of sodium atom 1 into 2, that is equal to 2. And chlorine, number of chlorine atom is also changed. The number of chlorine atom 1 into 2 is equal to 2. Now the equation is balanced. Barium chloride plus sodium sulfate gives barium sulfate plus NaCl. Okay. Next question. Then the symbol, state symbol for the following reaction. Solution of barium chloride and sodium sulfate in water. That means these are dissolved in water. Aqueous barium chloride and aqueous sodium sulfate. These are dissolved in water and will react to give insoluble barium sulfate. Insoluble barium sulfate. Insoluble, that is it will precipitate out. Insoluble. That means barium sulfate is in solid state. Solid state. Then, and the solution of sodium chloride. Solution of sodium chloride. Aqueous sodium chloride. Aqueous. Solution of solution. It's dissolved in water. So, aqueous sodium chloride. Then next one, sodium hydroxide solution in water. NaOH. React with the hydrochloric acid. Hydrochloric acid is HCl in water. That means sodium hydroxide dissolved in water and HCl dissolved in water. Mix these two solutions and to produce sodium chloride solution and water. NaCl plus water. Check if this equation is balanced or not. Number NaOH and HCl are reactants and NaCl and H2O are products. NaOH and HCl are reactants and NaCl and H2O are products. Number of sodium atom is equal to 1. Number of oxygen atom in the reactant side is equal to 1. Number of hydrogen atom in the reactant side. In NaOH only one hydrogen atom, but in HCl it's also have one hydrogen atom. Total number of hydrogen atom in the reactant side 1 plus 1, it is 2. And number of chlorine atom, that is 1. In product side, number of sodium atom is 1, number of chlorine atom is 1, number of hydrogen atom is 2, H2O, and number of oxygen atom is 1. Is this equation is balanced or not? Yes, this equation is balanced because number of each atom on the reactant side is equal to number of each atom on the product side. Sodium 1, oxygen 1, hydrogen 2, chlorine 1. So this equation is balanced. Okay, is it clear? This equation is already balanced. Then balance this equation. Balance the following chemical equation. HNO3 plus calcium hydroxide. HNO3 is nitric acid. It reacts with the calcium hydroxide to form CaNO3 twice. CaNO3 twice is calcium nitrate and water. Next one is NaOH plus sulfuric. NaOH is sodium hydroxide plus H2SO4. H2SO4 is sulfuric acid to form Na2SO4. Na2SO4 is sodium sulfate and water. Next one is NaCl, sodium chloride plus AgNO3. AgNO3 is silver nitrate. Silver nitrate to form AgCl. AgCl is silver chloride and NaNO3. NaNO3 is sodium nitrate. Then next one, BaCl2. BaCl2 is barium chloride and H2SO4. H2SO4 is sulfuric acid. BaSO4 is barium sulfate and HCl. HCl is hydrochloric acid. Do it as homework. Okay. Today we are going to discuss types of chemical reaction. Types of chemical reaction. First type is combination reaction. Combination reaction. Suppose A and B are two different compound or elements. It's react to form a product AB. A and B are two different substances. It's react to form a product AB. A and B combine to form AB. This type of reaction is called combination reaction. A and B are different substances. It combine to form a new product. That new product is AB. A plus B gives AB. This type of reactions are combination reaction. Then how to define combination reaction? When two or more substance like elements or compound, that means A or B, maybe elements or compounds, two or more substance combine to form a single product. The reactions are called combination reaction. So, when two or more substance like elements or compounds combine to form a single product, the reaction are called a combination reaction. A plus B combine to form a single product. A single product is AB. This type of reaction is called combination reaction. For example, calcium oxide CaO. It is also known as quicklime. Calcium oxide is quicklime. Quicklime react with the water. Calcium oxide, it's a quicklime. It's react with the water molecule to form calcium hydroxide. CaOH twice. Calcium hydroxide is slaked lime. Calcium oxide react with water to form calcium hydroxide and plus heat. That means in this reaction it emit heat energy. Calcium oxide react with water to form calcium hydroxide and it also emit heat energy. This is a type of combination reaction. Then another example, carbon react with oxygen. Carbon react with oxygen to form carbon dioxide. Carbon is an element, oxygen is a molecule, and element and a molecule combine to form a compound. Compound is carbon dioxide. So this is a type of combination reaction. A and B combine to form a single product. Carbon and oxygen combined and to form a single product, carbon dioxide. So this one is also an example of combination reaction. Calcium oxide and water, it's combined to form a single compound. Compound is calcium hydroxide. Calcium hydroxide is also known as slaked lime. What is slaked lime? And calcium oxide, common name of calcium oxide is quicklime. Another example is hydrogen. Hydrogen molecule react with the oxygen molecule. Hydrogen molecule react with the oxygen molecule to form water. Hydrogen molecule, it's a molecule. It's react with the another molecule. Another molecule is oxygen. To form a product is water. Water is a single product. So, two or more elements combine to form a single product. That type of reactions are called a combination reaction. Two or more substance. Here hydrogen and oxygen are the substance, or hydrogen and oxygen are the reactant. Two or more substance or reactants react to form a single product. Note the point, single product. React to form a single product. The reaction is known as combination reaction. when two or more substance like elements or molecule or compounds combine to form a single product, single product. In combination reaction, only a single product will formed. Combine to form a single product, the reaction are called a combination reaction. Okay. Some example are combination reaction of calcium oxide and water to form calcium hydroxide, and carbon and oxygen combine to form carbon dioxide, and hydrogen and oxygen combine to form water molecule. These are some examples for combination reaction. Then second type reaction is decomposition reaction. Decomposition reaction. Actually, it is reverse of combination reaction. Combination reaction means two or more elements combine and to form a compound. In decomposition reaction, a compound decomposes to form two or more elements, two or more substance, two or more elements or compounds. Decomposition reaction is a reverse of combination reaction. Combination reaction എന്തായിരുന്നു? Combination reaction is A plus B. It's combined to form AB. But decomposition reaction is a reverse process. AB is decomposed. Decompose means breakdown. AB is breakdown and to form a new product. More than one product is formed. More than one products are formed. AB decomposed to form A plus B. A single compound breaks down into two or more simpler substances. In decomposition reaction, a single compound breaks down into two or more simpler substance. Breaks down. That means decompose. A single compound decomposes into two or more simpler substance. AB is a single compound. It's decomposed to form A and B. But in the combination reaction, two or more substance combined and to form a single compound. But in decomposition reaction, a single compound decompose or break down into two or more simple substance. Single compound decompose or break down into form two or more single substance. That type of reactions are called decomposition reaction. Decomposition reaction is just opposite of combination reaction. Combination, combine. Two or more elements combine to form a molecule. A single product will form. But in combination reaction, a single compound break down into smaller molecule or smaller substance. That is decomposition reaction. Decomposition means breakdown. Single compound break down or decompose. എങ്ങനെ വേണമെങ്കിലും പറയാം കേട്ടോ. A single compound break down or decompose. Decompose into two or more simpler substance. Okay. Then types of decomposition reaction. Decomposition reaction classified into three types. Decomposition reaction classified into three types. Thermal decomposition reaction, electrolytic decomposition reaction, and photochemical decomposition reaction. What are they? Thermal decomposition reaction, electrolytic decomposition reaction, and photochemical decomposition reaction. Thermal. In thermal decomposition reaction, the decomposition process using heat energy. The decomposition process carried out or using in the presence of heat energy. Thermal decomposition reaction. Thermal means heat. The decomposition process, the thermal decomposition is using heat energy. And electrolytic decomposition. In electrolytic decomposition, here we are using electricity. Correct. Electricity. And photochemical decomposition. In photochemical decomposition reaction, photo means light. Yes, correct. Here we are using light energy. Light energy. So, decomposition reaction again classified into three types: thermal decomposition reaction, electrolytic decomposition reaction, and photochemical decomposition reaction. Is it clear? Thermal, electrolytic, and photochemical. Thermal means temperature, heat. That means thermal decomposition reaction using heat energy. And electrolytic decomposition reaction, electrolytic, it's using electricity. And photochemical decomposition reaction, photo means light, using light energy. Then first we are going to discuss thermal decomposition. Thermal decomposition. This is a decomposition reaction. FeSO4. FeSO4 is ferrous sulfate. Ferrous sulfate is decomposed to form Fe2O3, ferric oxide, and Fe2O3, ferric oxide, SO2, sulfur dioxide, and SO3, sulfur trioxide. FeSO4, ferrous sulfate, it's a single compound. It's decomposed to form three products. Decomposed to form three products. That means it's a decomposition reaction. Here, decomposition in the presence of heat energy. So, this reaction is a thermal decomposition. Thermal decomposition reaction. FeSO4. FeSO4 decomposed in the presence of heat energy to form Fe2O3, SO2 and SO3. Fe2O3, SO2 and SO3. FeSO4 is ferrous sulfate. Ferrous sulfate. Fe2O3 is ferric oxide. Ferric oxide. SO2 sulfur dioxide. SO3 sulfur trioxide. This S stands for FeSO4, ferrous sulfate in solid state, and Fe2O3S, that means ferric oxide in solid state. SO2G, that means sulfur dioxide in, yes, very good, gaseous phase, and SO3G, that is sulfur trioxide in gaseous phase. So this is an example for thermal decomposition reaction. Then next example is decomposition of calcium carbonate. Calcium carbonate decomposes in the presence of heat. Decompose in the presence of heat to form calcium oxide and carbon dioxide. Calcium carbonate is also known as limestone. Calcium carbonate is also known as limestone. Limestone decomposes in the presence of heat to form calcium oxide. Calcium oxide is also known as quicklime. So what is quicklime? Quicklime means calcium oxide. What is limestone? Limestone is calcium carbonate. And ferrous sulfate is FeSO4, ferric oxide is Fe2O3. Here calcium carbonate, it's a single compound. It's decomposed to form two smaller molecules, calcium oxide and carbon dioxide. Decomposed to form two smaller molecules. So this is an example for decomposition reaction. Here we are using heat energy. So this is thermal decomposition. Calcium carbonate decomposes in the presence of heat to form calcium oxide and carbon dioxide gas. Another example is decomposition of lead nitrate. Lead nitrate, it is PbNO3 twice. PbNO3 twice is lead nitrate. It decomposes to form PbO. PbO is lead oxide. Lead oxide. NO2. NO2 is nitrogen dioxide and oxygen. PbNO3, lead nitrate, is a single compound. It decomposes to form three compounds. It decomposes to form three compounds, or it's react to heat to form three compounds. So this is an example for decomposition reaction, and here we are using heat energy. So this is an example for thermal decomposition reaction. Decomposition in the presence of heat energy. Decomposition in the presence of heat energy. Okay. So decomposition reaction classified into three types: thermal decomposition reaction, electrolytic decomposition reaction, photochemical decomposition reaction. Thermal decomposition reaction using heat energy. Next one is electrolytic decomposition reaction. Electrolytic decomposition reaction using electricity. Electricity. Example, electrolysis of water. Example, electrolysis of water. Electrolysis of water. What is electrolysis? Electrolysis of water means splitting of water molecules or decomposition of water molecules in the presence of electricity. Water molecules split to liberate hydrogen gas and oxygen gas. H2O, it's a single compound. It decomposes or split to form hydrogen gas and oxygen gas. Here two gases are formed. Water molecule split to form two products. This is an example of electrolytic decomposition, electrolysis of water. Here, oxygen collected in the anode. Oxygen collected in the anode and hydrogen collected in the cathode. Oxygen gas, hydrogen. Water decomposed to form hydrogen gas and oxygen gas, and oxygen collected in the anode, that is positive terminal of the battery, and hydrogen gas collected in the cathode side. Hydrogen gas collected in the cathode side. Then note the volume of the oxygen gas and hydrogen gas. Volume of the oxygen gas and hydrogen gas. This one is oxygen. And this one is hydrogen gas. Density of oxygen and hydrogen gas is very low. So it's collected here. Then check the volume. Which is higher? Is hydrogen. Volume of hydrogen is greater than volume of oxygen. That means more hydrogen molecules are formed. Okay, hydrogen is collected in the cathodic side and oxygen molecule or oxygen gas collected in the anode. Electrolysis of water is an example for electrolytic decomposition. Water molecule decompose or split to form hydrogen and oxygen. Then next decomposition reaction is photochemical decomposition. Photochemical decomposition. Photo means light. So here the decomposition process carried out in the presence of sunlight. Decomposition process carried out in the presence of sunlight. AgCl. AgCl is silver chloride. Silver chloride decomposed to form silver and chlorine. Silver chloride, it's a single compound. It decomposes to form silver and chlorine gas to form two products. So it's a decomposition reaction. Here this reaction carried out in the presence of sunlight. So this is an example for photochemical decomposition reaction. One molecule split into two or more substance, that is called decomposition reaction. AgCl changed to Ag and Cl2. One molecule, one compound changed to two or more substance. So the reaction is decomposition, and here decomposition reaction carried out in the presence of sunlight. Decomposition reaction carried out in the presence of sunlight. So this type decomposition reaction is called a photochemical decomposition reaction. What is photochemical decomposition reaction? Photo means light energy, sunlight. AgCl is a white colored crystal. AgCl, it's a white colored crystal. Then it reacts with sunlight to form silver. Silver is a black colored or grey color. Grey. Gray colored substance. So AgCl kept in sunlight, the white colored crystal changed to gray color. White colored crystals, white crystal changed to gray color. That means AgCl react with the sunlight to form or to change Ag and it liberate chlorine gas. Okay. Another example is decomposition of silver bromide. Silver bromide decomposed to form silver and bromine gas. Silver bromide, it's a single compound. It reacts to form two substance, two products. That means it's a decomposition reaction. Here, silver bromide react in the presence of sunlight. Silver bromide react in the presence of sunlight. So, this is an example for photochemical decomposition reaction. AgCl, silver chloride, is a white crystal, but silver bromide is yellow powder. Silver bromide is a yellow powder. It reacts with the sunlight. Silver bromide react with the sunlight, change into gray color. Because why? AgBr react with the sunlight, it changed to gray color. Yellow colored AgBr react with the sunlight to form a gray color product. Why? Yes, AgBr react with yellow colored AgBr, yellow or any colored AgBr react with the sunlight to form silver. To form silver, the color of silver is gray color. Color of AgBr is yellow color. AgCl is white crystals. Okay. Then third type reaction is displacement reaction. First one is combination reaction, second one is decomposition reaction, and third one is displacement reaction. Displacement reaction. Here, A plus BC react to form AC plus B. A is a substance, A is an element. It reacts with BC. BC is a compound to form AC and B. This type of reaction is called displacement reaction. Here A displaces B. A displaces B to form AC. Is it clear? A displaces B and to form AC. A displaces B and to form AC and B. This type of reaction is called displacement reaction. A is in elemental form, B is in the compound. An element displaces another element in the compound to form a product. Here, the reactivity of A and B. Check the reactivity of A and B. Reactivity of A is greater than reactivity of B. That means the more reactive element displaces less reactive element. A is more reactive than B. So, A displaces B. The reactivity of element, more reactive element displaces less reactive element. A is more reactive than, if A is more reactive than B, so it displaces B and to form AC and B. Is it clear? This type of reaction is called displacement reaction. A more reactive element displaces a less reactive element. More reactive element displaces less reactive element to form its elements from its compound. This type of reaction is called displacement reaction. More reactive element in the elemental form and less reactive element in the compound. It's displaced and to form another product. That type of reaction is called a displacement reaction. So, more reactive element displaces less reactive element from its compound. A is more reactive than B. So, A displaces B from its compound to form AC and B. See this example. Iron Fe react with the copper sulfate CuSO4 to form FeSO4 and copper Cu. FeSO4 is ferrous sulfate or iron sulfate. Here, check the reactivity of iron and copper. Reactivity of iron and copper. Reactivity of iron is greater than reactivity of copper. By heard this. Reactivity of iron is greater than reactivity of copper. So, according to displacement reaction, a more reactive element displaces a less reactive element from its compound. Iron is more reactive than copper. So, iron displaces copper from its compound. Iron displaces copper from its compound. Fe displaces copper from copper sulfate. So, Fe displaces copper from copper sulfate to form FeSO4. FeSO4 and copper, because iron is more reactive than copper. Another example is zinc plus copper sulfate to form zinc sulfate plus copper. Zinc plus copper sulfate to form zinc sulfate and copper. Here, the reactivity of zinc is greater than reactivity of copper. So, zinc displaces copper from copper sulfate and to form zinc sulfate and copper. Here, lead react with the copper chloride to form lead chloride and copper. Here, the reactivity of lead is greater than reactivity of copper. So, lead displaces copper from its compound. Here its compound is copper chloride. Lead displaces copper from copper chloride to form lead chloride and copper. By heart, this reactivity range. Iron is more reactive than copper. Iron, zinc, lead are more reactive than copper. Okay, suppose Cu plus ZnSO4 gives CuSO4 plus Zn. Is this possible? Copper plus zinc sulfate gives copper sulfate plus zinc. Is this possible? Yes, it's not possible, because here, according to this equation, here copper displaces zinc. Check the reactivity. Reactivity of copper and zinc. Which is greater? Reactivity of zinc is higher than copper. Reactivity of zinc is higher than copper. So, copper can't displace zinc from its compound. Copper can't displace zinc from zinc sulfate. So, this reaction is not possible. Cu plus ZnSO4 gives CuSO4 plus Zn. This reaction is not possible, because reactivity of copper and zinc. Zinc is more reactive than copper. Zinc is more reactive than copper. So, copper can't displace zinc from its compound. Okay. Then, is it clear? More reactive element displays less reactive element. More reactive element displays less reactive element from its compound. The reactivity order, iron, zinc and lead is more reactive than copper. Next type of reaction is double displacement reaction. Double displacement reaction. It's a simple equation. AB plus CD gives AD plus CD. AB plus CD gives AD plus CD. AD and CB. Okay, AD and CB. Exchange of ions between two compounds are called double displacement reaction. Exchange of ions between two compounds. Both the cation and anions are exchanged and to form new products. That type of reaction are called double displacement reactions. Exchange of ion between two compounds. For example, sodium sulfate, Na2SO4 react with barium chloride, BaCl2. Sodium sulfate in aqueous, that means sodium sulfate dissolved in water. barium chloride in aqueous. That means barium chloride dissolved in water. Sodium sulfate and barium chloride dissolved in water. That's here indicate aqueous. Sodium sulfate react with barium chloride to form barium sulfate. Barium sulfate. Cations and anions are exchanged. Barium sulfate and sodium chloride. Barium sulfate and sodium chloride. Exchange of ions between two compounds. Exchange of ions between two compounds. Barium combined with the sulfate and sodium combined with the chloride ion to form barium sulfate and sodium chloride. This type of reaction is called a double displacement reaction. Double displacement reaction. Okay. Then here sodium sulfate react with the barium chloride. Sodium sulfate in aqueous solution. Sodium sulfate in aqueous solution. Barium chloride in aqueous solution. It react to form barium sulfate. Barium sulfate in solid form. Barium sulfate in solid form and to form NaCl. It's an aqueous solution. Aqueous NaCl solution. Here barium sulfate in solid state. That means sodium sulfate react with the barium chloride. A white colored precipitate will form. That precipitate is barium sulfate. Precipitate because barium sulfate is in solid state. It precipitates out. That type of reaction is called a precipitation reaction. So, precipitation reactions are a type of double displacement reaction. It's a type of double displacement reaction where an insoluble solid that is precipitate is formed. Here in this reaction the precipitate is barium sulfate. Precipitate is barium sulfate. Sodium sulfate react with the barium chloride to form barium sulfate. Okay. And barium sulfate is an insoluble substance or precipitate. This type of reaction, in any reaction, any insoluble substance is formed. That reaction is an example of precipitation reaction. If all products are soluble, that reaction is not a precipitation reaction. If any one of the product is insoluble, the reaction is called a precipitation reaction. All products are soluble, the reaction is not a precipitation reaction. Then next one, oxidation and reduction. Oxidation and reduction. Redox. Redox means reduction and oxidation reaction. Oxidation and reduction reaction or redox reaction. Redox means reduction and oxidation. Then oxidation. Oxidation means Oxidation means addition of oxygen. Addition of oxygen. Gain of oxygen or addition. Addition of oxygen. Oxidation means addition of oxygen or removal of hydrogen. What is oxidation? Means addition of oxygen or removal of hydrogen. Addition of oxygen or removal of hydrogen. Both are oxidation. That type of reaction is called oxidation reaction. And reduction. Reduction is removal of oxygen. Oxidation is addition of oxygen. Reduction is removal of oxygen. Removal of oxygen or addition of hydrogen. In other words, oxidation is gain of oxygen or loss of hydrogen. And reduction is loss of oxygen or gain of hydrogen. It's clear. Oxidation, oxygen. That means addition of oxygen or gain of oxygen or removal of hydrogen or loss of hydrogen. Reduction, it reduce. How to reduce? It release oxygen, removal of oxygen or gain of hydrogen. If oxidation and reduction takes place simultaneously, that reaction is known as redox reaction. Oxidation and reduction takes place simultaneously, that reaction are known as Redox reaction. Redox. Reduction and oxidation. Two terms. Reduction and oxidation. The two terms combined and to form redox. Reduction and oxidation. Reduction and oxidation take place simultaneously. The reaction is known as a redox reaction. For example, CuO plus H2 gives Cu plus H2. Here, CuO changed to Cu. Copper oxide changed to copper. CuO changed to Cu and H2. Hydrogen changed to H2O. Hydrogen changed to H2O. CuO changed to Cu. CuO, copper oxide. It remove oxygen and to form copper. Removal of oxygen or loss of oxygen. That reaction is called yes, correct, reduction. Removal of oxygen, reduction. So this process is reduction. CuO changed to Cu. Here this oxygen is removed. CuO changed to Cu. Here oxygen is lost. Lost one oxygen atom and to form copper. Removal of oxygen or addition of hydrogen. Both are same. Here oxygen is removed. So this reaction is reduction. And reduced species. Which one is reduced? Which one is reduced? Which one? Yes. CuO. CuO is reduced. CuO is reduced. CuO is reduced and to form Cu. And the reduction product is copper. And reduced substance is CuO. So, which one is reduced? CuO is reduced. CuO is reduced and the reduced product is copper. And here H2. H2 changed to H2O. Here only two hydrogen atoms are present. It's a hydrogen molecule. Two hydrogen atoms combined and to form hydrogen molecule. Here it's combined with the oxygen and to form water molecule H2O. That means H2 molecule combined with the oxygen. Addition of oxygen. Here addition of oxygen. That means this one is oxidation reaction. Oxidation. Hydrogen molecule add oxygen to form water. Oxidation is addition of oxygen or removal of hydrogen. Here oxygen is added. So the process is oxidation. And oxidized species. Which one is oxidized? Yes, correct. H2 is oxidized, not H2O. Oxidized species is H2. H2 is oxidized. And reduced product. Suppose reduced product ചോദിക്കുകയാണെങ്കിൽ reduced product. Reduced product. CuO is reduced and the product is Cu. Cu is reduced product. Cu is the reduced product and oxidized product. Hydrogen is oxidized and the oxidized product is water. H2O is oxidized product. H2O is oxidized product. This reaction CuO is reduced, H2O is oxidized and Cu is the reduced product and H2O is the oxidized product. What is oxidation and reduction? Oxidation is gain of oxygen or loss of hydrogen and reduction is just opposite, loss of oxygen or gain of hydrogen. Here CuO release oxygen atom and to form copper. So the reaction is reduction and H2 change to H2O. H2 accept oxygen to form H2O. Addition of oxygen, that is oxidation. Oxidized species H2, oxidized product water, and reduced species CuO, reduced product Cu. Okay. Then another equation, ZnO plus carbon gives Zn plus CO. Find oxidized and reduced species. Find it. Here, ZnO change to Zn. ZnO change to Zn. Zinc oxide release oxygen and to form zinc. Removal of oxygen. Removal of oxygen is very good. Reduction. Removal of oxygen is reduction. Reduction. And here C. Carbon change to carbon monoxide. CO. Carbon change to CO. Addition of oxygen. Addition of oxygen is oxidation. Oxidation. Then, which is the reduced species? Is correct. ZnO is the reduced species and C is the oxidized species. C is the oxidized species. ZnO is the reduced species. C is the oxidized species. And reduced product is Zn and oxidized product is carbon monoxide. CO. Another example, MnO2 plus 4HCl gives MnCl2 plus 2H2O plus Cl2. MnO2, manganese oxide. Here MnO2 change to MnCl2. MnO2 change to MnCl2. MnO2, it's released to oxygen atom and combined with the 2 chlorine atom. Release to oxygen atom. Removal of oxygen, that is reduction. Reduction. MnO2 is reduced. MnO2 is reduced. And HCl. HCl change to Cl2. HCl change to Cl2. Here hydrogen atom is removed. Removal of hydrogen atom. Addition of oxygen or removal of hydrogen. That is oxidation. This is oxidation reaction. And HCl is oxidized species. Is it clear? HCl is oxidized species. Then recall activity. Recall activity 1.1. Where a magnesium ribbon burns with a dazzling flame in air and changes into a white substance as magnesium oxide. Is magnesium being oxidized or reduced in this reaction? Magnesium is oxidized or reduced? Find it. First write the chemical equation. Magnesium, Mg, react with the oxygen, O2, to form magnesium oxide, MgO, magnesium oxide. Then check magnesium, Mg change to MgO and O2 change to MgO. Mg change to MgO. Addition of oxygen. This step is oxidation. And O2. Here already 2 oxygen atoms are present. O2 change to MgO. In MgO only 1 oxygen atom is present. So removal of oxygen. Removal of oxygen is reduction. So reduced species is oxygen and oxidized species is magnesium. Is magnesium being oxidized or reduced? Magnesium is oxidized. Magnesium is oxidized. Magnesium is oxidized and oxygen is reduced. Okay, is it clear? Then next topic, energy change in chemical reaction. Energy change. It's two types, exothermic reaction and endothermic reaction. Exothermic reaction and endothermic reaction. Exo means exit, to liberate. That means it liberates energy. If the reaction carried out in a certain condition, it liberates certain amount of energy. That reaction is called exothermic reaction. And it absorbs certain amount of energy. It's called endothermic reaction. If energy is liberated in the form of heat. This is heat, that is exothermic. The reaction in which heat is liberated, heat energy. The reaction in which heat is released. Heat is released along with the formation of products are called exothermic chemical reaction. For example, calcium oxide react with water. Calcium oxide, Q-climates react with water to form calcium hydroxide and it liberates heat energy. So this reaction is an example of exothermic reaction. Exothermic because in this reaction it liberates heat energy. Another example is burning of natural gas or burning process. In burning of natural gas, methane CH4 react with oxygen to form carbon dioxide, water and it liberates heat energy. We know that burning process, all burning processes are exothermic. It liberates heat energy. Another example is respiration process. Respiration. C6H12O6, glucose molecule. Glucose molecule react with the oxygen to form carbon dioxide and water and it release energy. So this is also an exothermic reaction. And endothermic. Endothermic means reaction that absorb energy. The substance which absorb energy to form a particular product. That reaction is called endothermic. Endo means it absorbs certain amount of energy. For example, photosynthesis. Respiration is an exothermic reaction because it releases energy. But photosynthesis is an endothermic reaction. Carbon dioxide plus water in the presence of sunlight. It absorbs light energy in the presence of sunlight. So it's absorbed light energy to form glucose, oxygen and a water molecule. In this reaction, in photosynthesis process, it's absorbed light energy. So it's an endothermic reaction. And all decomposition reactions are endothermic. Decomposition reactions. The next topic is effect of oxidation in daily life. Effect of oxidation in daily life. First effect is corrosion. What is corrosion? Some metals like iron, silver, copper, etc. is easily react with the atmospheric air or moisture and to form a new product. That process is called corrosion. The process where metals are attacked by substance such as moisture, acid, air, etc. are called corrosion. For example, rusting of iron. Iron react with water vapors in the atmosphere to form rust. Rust is chemically iron oxide. It's a reddish brown colored substance, iron oxide. Iron react with the atmospheric moisture or air to form rust. Rust is iron oxide. The color of iron oxide is reddish brown color. Rusting of iron forms reddish brown iron oxide. Another example is tarnishing of silver. We know that silver ornaments. Silver ornaments react with the air to develop a black coating on the surface. Silver ornaments, it's easily react with. That means silver is easily react with the air and to develop a black coating on the surface. Black coating on the surface. This is also an example of corrosion. Tarnishing of silver. Silver develops black coating. And green coating on copper. Some copper vessels. Copper vessels is react with the oil or atmospheric moisture to form a green colored coating. That is also an example of corrosion. Green coating on copper. Then corrosion causes damage to metal object and structure. Rusting of iron is an best example. Then how to prevent corrosion? Yes, painting, apply oil, grease and galvanization or alloying. Painting, oiling, greasing, galvanization or alloying. These are the prevention method of corrosion. Next one is rancidity. Effect of oxidation in daily life. First one is corrosion. Next one is rancidity. Metal is oxidized and it will corroded or rancidity will formed. Rancidity. What is rancidity? Oxidation of fat and oils. Oxidation of fats and oil. Oxidation of fats and oil in food causing unpleasant smell and taste. That is called rancidity. The fat and oil oxidized to form a new substance with a unpleasant smell and taste. That is called rancidity. Then how to prevent rancidity? To use antioxidant. Storing food in airtight containers, because oil and fat it react oxidized in the presence of air. Oil and fat react with the oxygen and it will become oxidized and to form some products. That products have unpleasant smell and taste. So storing food items in a airtight container. Next method is refrigeration. Then flushing food package with a nitrogen gas. Food package with the nitrogen gas. Then application of chemical reactions. Some applications are here. Whitewashing. One of the application is whitewashing. So many applications are there. One of the application is whitewashing. Only 3 applications are right here. Whitewashing. Whitewashing using calcium hydroxide, CaOH twice. The common name of calcium hydroxide is slaked lime. Using calcium hydroxide which react with the carbon dioxide to form calcium carbonate. Calcium hydroxide plus carbon dioxide to form calcium carbonate and water. It's using whitewashing. Then photography. Using photochemical decomposition of silver halide. Photography. Using photochemical decomposition of silver halide. We know that silver halide, silver chloride or bromide, decomposed in the presence of sunlight to form silver. This application is used in photography. AgCl or AgBr. This application is used in photography. Photochemical decomposition of silver halide. Silver halide like silver chloride or bromide. Here silver is precipitated. Silver halide react with light to form silver. Then metallurgical process. Extracting metals from their ore. Extraction process from its ore. Then do this problem. Identify the substance that are oxidized and the substance that are reduced in the following reaction. For Na plus O2 gives Na2O. Na plus O2 gives Na2O. Here, sodium changed to Na2O. Sodium changed to Na2O. Addition of oxygen. Addition of oxygen is oxidation. Oxidation. This process is oxidation. And the oxidized species. Identify the substances that are oxidized. Which one is oxidized? Yes, sodium is oxidized. Sodium is oxidized. Then O2. O2 changed to Na2O. O2 is also changed to Na2O. O2. Here two oxygen atoms are present, but in the product Na2O, only one oxygen atom is present. That means removal of oxygen. One oxygen atom is removed. Removal of oxygen atom is reduction. This one is reduced. Which one? Oxygen is reduced. Oxygen is reduced and CuO, Na is oxidized. Oxygen is reduced and Na is oxidized. Another example, CuO plus H2. CuO plus H2 gives Cu plus H2O. Cu plus H2O. This is a type of displacement reaction. Hydrogen displaces oxygen. Okay. Then find oxidized and reduced species. CuO plus H2 gives Cu plus H2O. CuO changed to Cu. CuO changed to Cu. Removal of oxygen. Removal of oxygen is reduction. Correct. Then next one. H2 changed to H2O. H2 changed to H2O. H2 to H2O. Addition of oxygen. Addition of oxygen is oxidation. And the oxidized species is hydrogen. And the reduced species is CuO. If the question is reduced product, the reduced product is copper and the oxidized product is water. And reduced species is CuO and the oxidized species is hydrogen, H2. Then next problem. Which of the statement about the reaction below are incorrect? 2Pb plus carbon gives Pb plus CO2. Lead is getting reduced. Carbon dioxide is getting oxidized. Carbon is getting oxidized. Lead dioxide is getting reduced. So, which of the statements are correct? Incorrect. Which of the statements about the reaction below are incorrect? Incorrect statements. Then do this. PbO plus carbon gives Pb plus CO2. PbO plus carbon gives Pb plus CO2. PbO changed to Pb. PbO changed to Pb. PbO, lead oxide changed to lead. Removal of oxygen. Removal of oxygen is reduction. Reduction. And carbon changed to carbon dioxide. Carbon changed to carbon dioxide. Addition of oxygen. Addition of oxygen is oxidation. Oxidation. That means carbon is oxidized and PbO is reduced. Oxidized species. Oxidized species, carbon. Reduced species, PbO. Then oxidized product, Oxidized product. Carbon is oxidized to form carbon dioxide. Carbon dioxide is the oxidized product, and reduced product PbO reduced to form Pb. Then check the statement. Lead is getting reduced. Which one is reduced? Lead oxide is reduced. So first statement is wrong. Lead oxide is getting reduced. Lead is the reduced product. Then carbon dioxide is getting oxidized. Oxidized product. Oxidized species is carbon. Carbon dioxide is getting oxidized. So this statement is also wrong. Carbon is the oxidized product. Carbon is getting oxidized. Carbon is the oxidized species. Carbon is getting oxidized. Then carbon is getting oxidized. It's correct. And lead oxide is getting reduced. It's also correct. Then find the incorrect statement. Incorrect statement are A and B. Correct answer is option 1. Option 1. Option 1 is the incorrect answer. A and B. Lead is getting reduced and carbon dioxide is getting oxidized. It's wrong. Lead is the reduced product and CO2 is the carbon dioxide is the oxidized product. Okay. Thank you. See you on next class.